Hi, today we shall be looking at one A-level question on lattice energy from your paper 4 to May-June 2010. Now, the question goes, it reads, describe and explain how the solubility of the surface of the group 2 elements vary down the group. The first thing you need to do is try and write down the formula for enthalpy change of solution. Okay, so the standard enthalpy change of solution is equals to the standard enthalpy change of hydration minus your standard enthalpy change of your lattice energy. Okay, or better still, we can be using the hydration energy minus the lattice energy for short. And looking at the surface of the group 2, the solubility of the surface decreases down the group, down the group. Okay, so it decreases down the group. And why is that so? This is because the hydration energy as well as the lattice energy decrease as you move down the group. Okay, now you can elaborate a bit on this. Why do you think the hydration and the lattice energy decrease down the group? This is due to increase in ionic radius, down the group, right? Resulting in what? Resulting in weaker bonds, right? Creating weaker bonds. So you're gonna have weaker bonds. Now, moreover, when you have this decrease in your lattice, so these values become less exothermic. That's what I want you to take note of. It becomes less exothermic. Okay, so it becomes less exothermic. They become less exothermic, or better still, more endothermic. So that's why they decrease down the group, or that's how they decrease down the group. Good. Another thing you need to note here is that the hydration energy decreases in a larger value, okay? While the lattice energy decreases slightly. I'm changing my vocabulary here. Okay, I don't want to see the page decreases in a smaller value. So decreases slightly. Good. And this causes, or these, since they are plural, this cause the standard enthalpy change of solution to be more endothermic. That's it. Good. Let's go to the B part. You have a table here of the lattice energy. Here you have the lattice energy. Here you have the enthalpy change of hydration of your M2 plus gas. And the last rule you have your enthalpy change of hydration of the hydroxide ion. And you ask in Roman 1 to calculate the values of your standard enthalpy change of solution of magnesium hydroxide and for that of strontium hydroxide. So you have magnesium here and you have strontium here. Good. So what is the enthalpy change of solution? You already know the formula. So the formula here, if I can repeat that, is equals to the hydration energy minus the lattice energy. And what's the hydration energy? The hydration energy for the magnesium, you have magnesium that you can have Mg2 plus and what? 2OH minus. 2OH minus. So what's Mg2 plus? Minus 1890 plus minus 2 times plus you could look at, oh, let's just say, let me put it this way so they don't get confused. Plus in bracket 2 into a minus 550, right? Since the value is negative. So you're adding them actually because they form your magnesium hydroxide. Now minus your lattice energy. And what's your lattice energy? That's your minus 2993. That gives you, so if I use my calculator here, you have negative 1890 plus 2 times minus 550. That gives you that plus 2993. So you have just plus 3. Plus 3, you're going to have kilojoules per mole. So you can just put here 3 here. That's plus 3. So telling you that this value is endothermic, okay? That for strontium hydroxide would be, what strontium? The hydration of strontium will be minus 1, 4 plus 2 times minus T550 minus your lattice energy, which is 22467. That gives you, using my calculator, I have minus 1414 plus 2 times negative 550. Minus is plus, right? Plus 2467, and that gives you minus 47. So you're gonna put minus 47 here, and this is exothermic, okay? That's exothermics. Since the enthalpy change there is negative. And that's that about that B part. So can we go to Roman 2? Use your results in Roman 1 to suggest whether strontium hydroxide is more or less soluble in water. State any assumption. So it is what? More soluble. So strontium hydroxide is more soluble because, remember, you are asked to state any assumption you made. Use a result to suggest because what can you say? Because the enthalpy change of solution is exothermic, okay? And for any temperature or any assumption, you can say at constant temperature. So you can keep the temperature constant. Then keep it constant. Or you can, say a standard entropy or constant entropy. You can keep it that way. Good. Suggest whether strontium hydroxide will be more or less soluble in hot water than in cold water. Explain your reason. Now, since the enthalpy change of solution is exothermic, since it was exothermic, then it will be more soluble. It will be what? More soluble in cold water, okay? Since what? Your enthalpy change of solution is exothermic. Now, this is in accordance to Le Chatelier's principle, right? If you know what I'm talking about. So there's going to be a counter effect there. So that's based on Le Chatelier's principle. And that's that about that question, all right? Now, thank you for watching. Let me know your thoughts about this question, and don't forget to subscribe, like our content, and also comment on more doubt sessions as well as challenging A levels and IGCSE questions. Thank you for watching. See you.